Bletchley Park Science and Innovation Centre at the offices of Dynamic Imaging Analytics, where they are building the SuGRE-1 payload. Here is Anthony Evagora, who is going to tell us about designing and building the box that's going to go into space, that's going to take everything into space. So tell us what you need to consider when you're building something that's going to be going into space.
Okay, so some of the key things that you have to consider are strength, the mass, functionality, and whether it's going to work. So looking at this payload here, this is the battery box for the SuGRE-1 payload.
Oh right, so if this is the SuGRE-1 payload,
yes,
it's that bit on the side, isn't it? So this is what's going to power it.
So the item that you saw on the vibration table, so that was the payload, and then this is the battery box that's going to sit next to it on the rocket. So just looking at some of the key parts of this, so you see these pockets here. Yeah, so these were designed into the box to lightweight the box, so to reduce the mass, because each segment of mass costs money to fly into space, so you have to make it as light as possible. Every
gram counts.
Yes, but whilst keeping the strength. So these ribs keep the strength of the box whilst trying to keep the mass as low as possible. This is made of aluminium, which is light. However, it lacks certain strength properties, so you have to do things like helicoiling, which is when you insert stainless steel inserts into the screws to strengthen up your points of contact, but you can still use aluminium as your main material. This insert in here is made from a flexible resin material, 3D printed, so that is to absorb any shocks or vibrations this box gets, but it's still lightweight enough to be able to use in the rocket. So yeah, as you can see here on the CAD, the SuGRE payload was manufactured using the same techniques. So they all have these ribs to give the strength, however trying to make it as light as possible. That's even more important when you're doing very large missions, very large satellites and very large rockets, where a kilogram is a very big mass compared to.
So what is the total weight of SuGRE-1?
So this box here is around 3 kilograms, and each one of these boxes is around 3.5 kilograms. So this is particularly heavy for its size because of all the batteries inside. But this top box is virtually empty, so that is just a volume to allow the sculptures to fly around in microgravity. And this bottom box has the cameras and things, but it's much less in terms of, say, dense than that.
Has there been anything particularly challenging while you've been building this?
I think the main challenge on this project has been timescales. We've had to turn the project around very quickly. So generally on space projects you have a large budget and lots of time to do it. So we've had a very limited budget and we've had to turn it around in a very short amount of time. So getting everything right and having to think about every scenario in a short amount of time has been a challenge.
How's it gone? Has there been any complications? Has it gone quite smoothly?
No, it's gone very well so far, but we haven't launched it yet. So that's cool. And we've been working quite well with our American partners, so we've been helping each other through the process. So it's been good.
Excellent. So what's your day-to-day role here at Dynamic Imaging Analytics?
So I do a variety of different things. So I do a lot of mechanical design. I help out with the software and electrical side of things. And basically anything that needs doing. So with small companies you have to be prepared to do lots of everything, so which is part of it, which is what I enjoy. So,
excellent. So what's a typical day here?
Typical day, there is no typical day. So you come in and you might start on one thing and then somebody gets a phone call from a customer or something, and then the whole day changes and you have to do something completely different. So there isn't really a typical day, but mostly it is thinking about problems, finding solutions.
Oh, that's good. And how did you get into this? How did you get into this profession then?
So I started off doing a physics undergraduate at the University of Reading, and then finishing that and not really wanted to start a job. I wasn't ready to go and work, so I saw an advert for a PhD on notice boards, applied for that, got that. That was in the Open University here in Milton Keynes, and Neil Murray, who's my boss now, was my supervisor during my PhD. So I finished my PhD, I went into industry for a few years, did teaching for a little bit, and then I've come back into industry and I work here, building stuff for space, which is good.
Excellent. Thank you, Anthony, that's been really helpful. Good luck with the rest of the mission.
Thank you very much, and thanks for coming in.